raise your hand if this is your first time at a unstructured data meetup. Raise your hand really high. Wow, nice. Raise your hand if you are from out of town, if you don't live in San Francisco. Wow. And how many of you are here because of the Snowflake Summit? Nobody? No, I know some of you are because I talked to some of you. Very nice. Well, I'm really glad that you're here at our Unstructured Data Meetup. My name is Chris, and I work at a company called Zilliz. And it's a made-up word for zillions and zillions of unstructured data, which we all have, even in our laptops. We are the maintainers of open source Milvus, and we intentionally do not call this meetup Milvus because that would be really boring, because the problem that we're all really trying to solve is trying to get a lot of insights out of unstructured data. And there's a whole ecosystem of solutions that are out there to help us achieve that goal. Come on, people, we have seats in the front. Come on in, don't be shy. Don't worry, your neighbors will bite you. That is a true rumor. There's seats up over here too. So we have our meetups here in San Francisco. Usually they're once a month, but this is a lucky month. We actually are going to do another one next week because we have a lot of fabulous speakers. We also do this in the South Bay, in Berlin, New York City, Seattle, and we also just started one in Shanghai. And if you have an incredible project that you're working on, hit one of us up, and then we'll see if there's a speaking slot for you. Even if it's just, project that you just got started on and you just have, a couple of GitHub stars. There are people in this room that would love to see what you're working on. So don't be shy. And if you've never done that before, that's okay too, because a lot of us are more than happy to help you pull together your notebook and your presentation. So just raise your hand. One thing that we do at the end of these meetups is if you have a job opening, we'll ask you to go ahead and share that with this group, because there's always a lot of people that are looking for jobs. And Christy, who's one of our DevRels at Zilliz, informed me just a couple days ago that we've actually made some pretty great connections for people. So magic does happen here, not just on your phones. So today we have a couple of talks, and we actually have a community talk as well. Normally at this time, I would ask people if they've ever used Milvus. So let's see if anyone's actually heard or used Milvus. Raise your hand. Oh, actually not bad. So normally what Christy would ask is, or myself would ask, if you are interested in just sharing a little bit about your project using Milvus. But today we actually already have somebody that already nominated themselves. So we'll have a really quick demonstration from the team at Relari AI. But just keep that in mind if you want to share in your projects. This is all about community building, and we also want to make this super fun. So we're going to get started first. Our CEO, Charles, who's also very much a developer, would actually like to kick off with a couple of cool words. You are a developer. Yes. In fact, 10 points if you can actually, even better than this, if you can tell me what his handle is and why he has the handle, because it's, something the developers really like, I'll give you a hoodie. So you can come by and hit me up for that at the end. All right.
Thank you, Chris. Yeah, first of all, I want to thank you for joining us in this beautiful night, in this unstructured data meetup. So I'm going to, before I get into this quick opening, let me ask one question. How many of you are developers? Please raise your hand. Like more than 60% for sure, probably could get to more than 70%. And how many of you has already built a Gen AI application or a RAG solution? Probably half. Yeah, so you know that tonight we are going to talk about unstructured data, and tonight we are going to talk about various kind of RAG solutions, and that's the right place for you. And before I get started, please allow me to give a brief introduction. As Chris mentioned that I'm a lifetime developer. So before I started Zilliz, I was one of the founding engineer at Oracle Cloud Database System. And yeah, actually, to be honest, if I can pick another career track, I would rather to stay as an engineer because, but now, you know, the engineers at Zilliz, they don't even allow me to write any code because, yeah, you know, so that's, yeah, so, and you may find out that Zilliz is a word you are not probably not familiar with. Actually, it's a word made by ourselves, because we are trying to build something. We want to build a database for unstructured data. There's just such an enormous amount of unstructured data in the world. We want to build a world that present a large number. So we figure out that you know, Zilliz is represents zillion of zillions. It represents a large amount of unstructured data in the world. And you know, as an engineer, when I figure out this word, you know, we find out that it's cool because it's a palindrome. So, you know, it's a symmetric. So we pick up that word. We started building vector database systems since year 2019. And so that's about us. And we know that Gen AI is a new gold rush. So if we look at the Gen AI, we see that we need different tools. We need models. We need computations. We need the data. So you feed good data in, you get good results. If we take a close look of the data, you will see the data we are processing at this Gen AI era is different from the data we have been processed in the last 50 years, because it's all about unstructured data, images, videos, human voices, right? In recommendation system, we have a user behavior information. We have a geolocation information. In pharmaceutical industry, there are a lot of researchers, they are trying to make sense of 3D structure of proteins, 3D structure of molecules, and they're trying to discover new cures for certain disease out of this 3D, whether 3D structure of proteins or molecules. And so from a data perspective, modern AI, Gen AI is all about unstructured data processing and how we make sense of it. So that's why vector database in the past 1 year become such a hot topic. So because vector database is all about to manage your unstructured data, whether it's an image, voice, or video, and trying to make sense of it. Because it stores all these embedding vectors, and also it allows semantic retrieval on top of unstructured data. So we know that we have a lot of pictures, for example, in our photo album, but we cannot do, without a vector database, without a deep learning, we cannot retrieve the data by the contents. We have to look into the data and figure out the data by name, by metadata, which is not efficient. So yeah, so at Zilliz, we started building vector database systems in year 2018. We are, you know, we're the pioneer in this industry, and now we are so proud that we are the most production-ready vector database system in the world. Look at all these, you know, big companies, and they love us. They put Milvus in their production environment on a daily basis, and also. Milvus was designed and was famous for its scalability. So for example, on one single instance, we can accommodate more than 10 billion vectors. In one of our largest deployment, they put in more than 100 billion vectors. So you may, so just give you an idea about how much is 100 billion vectors. It's basically like the internet scale. So basically, you know, so if you want to index all this, every single web pages in the world, it's around like 900 billion in total. And so, you know, so Milvus is very, very scalable. It's, you know, it can work at a web scale. And so, yeah, so I know that in the following presentation, a lot of we have two speakers will talk about a rack system. But we know that a RAG basically you have a large language model. When you're trying to eliminate hallucination, and you use vector database to provide domain-specific knowledge to your large language model to get a more accurate answer. So this is a technical perspective. But what I'm going to see is from another perspective. From an economic perspective, I would say that RAG system is more a business model to gap between your private data and the public available data, because large language models, they are training by public available data on the internet data, but there are a lot of domain-specific data or your private data you don't want to give away. You want to give away to large language model companies because because that's not because you want to keep data sovereignty. So that's why with the RAG system you can keep data sovereignty without the loss of accuracy, and you can eliminate hallucination. And so last year we saw RAG became very, very hot, and we saw a lot of RAG system for documents, for text. And this year, with the release of these multi-modality models, we are beginning to see a lot of RAG system designed for multi-modality RAGs. So for example, you are not only put, fit into large language model the documents, but also your private images, your proprietary videos, and large language models like GPT-4 Omni can make sense of all this data from different modality. And I'm going to make a little bit of bold prediction here. We can check out next year whether I'm wrong. So I would say that next year, there are going to be foundation models. There are going to be large models for example, for recommendation systems. Because basically it's a pre-trained model for recommendation system. And in the RAG is going to play a very important role here that, the model was built by common human being interest and profile and the behaviors. But for every single online business, for every single e-commerce, you may have some specific behavior, just limited, belongs to your own customers. So you don't have to build a foundation model for recommendation system from scratch. You can grab a pre-trained model, and you can use a RAG system to enhance it with your private domain-specific user profile, user behavioral information. And to this end, we are actually working with NVIDIA on this open source project called Merlin. And if you guys are interested, check it out. And so other than that, actually, vector database has other applications, for targeted ads, for autonomous driving, even fraud detection, cybersecurity, and drug discovery, as I mentioned. And so let's just have a visit of 3 pillars of Gen AI. So models I made a mistake. It's models and computation. So model and computation, these 2 pillars are highly visited. There are a lot of investment in those 2 areas. But when it comes to data, it's much more quiet. So yeah, it's not I would say, like, we know data is very important, but it looks like it's a pillar that are highly underestimated in the past few years. That's why. But if we take a look for unstructured opportunity in unstructured data, it's not only about a vector database. It's all about the data ETL, data pipeline, data compliance. So basically, all these data components we built for structured data in the past 50 years, we got a chance to rebuild it, to reinvent it in the next 10 years, but built for unstructured data. So that's why we think that, for for the success, for the future of unstructured data, we cannot do it alone. We really want to build a community. That's why it was last year at Zilliz, even we are smaller, we're very small startup, and but we decided to host it and organize this unstructured data meetup for the community. So we want to foster the innovations and the collaborations in the space of unstructured data. Because in my opinion, I think the future of unstructured data is not only in the technology itself, but it's more in the community we are building today. And so, over the past 12 months that, we started from San Francisco, but we opened a few chapters globally. So right now we already have 6 chapters, and we plan to open another chapter in UK and Japan. So, and today, I would like to introduce, actually it's the first time we introduced this, so we want to announce that we are going to host the Unstructured Data Summit later this year. So it's going to be in San Francisco. It's going to be in the last quarter of this year. So preferably this October. And we plan it to be a 2-day event, and with more than 30 talks, and so yes. So if you are interested, please stay tuned. So we will post it. We will announce our website, our official website, very soon. And if you want to speak at this event, our call for paper will be ready pretty soon. And and thank you for coming here again for this event. Hope you enjoy the pizza and the drinks. And so a quick mention. So like today's food and the drink was sponsored by a cool company called Tecton, and the CEO will give a presentation later tonight. And welcome you, and thank you, and enjoy the presentations. Thank you.
Awesome. Our next speaker is Jiang, and Jiang is one of my coworkers, and he's got a really fancy title. He is the head of ecosystem and AI platforms at Zilliz. But fundamentally, what this means is if there's an opportunity for us to build an integration with any cool projects that you guys are working on, hit up this guy. And then his counterpart is Emily, so then she'll do co-marketing with you guys. So we want to make sure that, just as Charles articulated, we really want to make sure this ecosystem really thrives. A couple things about Jiang. So he's a Michigan guy, usually wearing his Michigan hat very proudly. So if you went to Michigan, or if you didn't, went to, I don't know, Ohio State.
Go blue if I see any Wolverine here.
But the other thing that I really respect about Jiang is that he actually worked at Google, and he actually worked on their search index in the back end. So very, very familiar with search. So with that, I'll let you take it away.
Well, thanks, Grace. Yeah, just like 2 minutes ago, I changed my title from ecosystem and AI platform to ecosystem and developer experience, because I think developer is really the key of our business. No, just kidding. So yes, I work on the ecosystem integrations. Like I work with a lot of great partners. We have, BentoML and my personal friend E from Radar AI. Here we work on the, building, foster a ecosystem of RAG system. For RAG, it has so many components, so that vector database is a core pillar of it, but not all of it. So we rely on our partners to build a easy to use and high quality user experience. Also, we are continuously improving our developer experience with a lot of content. We build demos on RAG. Today, I will talk a bit about multi-model RAG, which is kind of a new story that we are building at this moment. We also work with our customers, doing a showcase of image search, because vector database is not only used in RAG, it's used in many things. Like in the future, we'll maybe have an example showing how to use embedding models to do protein like how do you search for new drug in the protein space. So with that, I also did a little bit of social networking because I mean in AI you have to do that, right? Everything happens on Twitter and LinkedIn. So I also have my LinkedIn QR code here. So if you would like to connect after this. So today I will mainly talk about RAG with Milvus, but also with a touch of the Snowflake's technology. Snowflake's recently announced their Snowpark Container Service. So we also did the integration with that as part of our integration effort in this domain. So I will also show some notebooks and instructions on how to use Milvus in the container service. So before we talk about any technical detail, I want to lay out the foundation of unstructured data and the revolution from AI. So I work on Google search, like we call it information retrieval, kind of boring words, not AI. I worked on it for a few years, and the way we did that in the past decade is that we have a gigantic service mesh of machine learning models, and we extract hundreds to thousands of labels from the images and web docs. And then we build a reverted index, and then we do token-based retrieval so that if you have, Eiffel Tower, the word matching an image that was tagged with Eiffel Tower, the label, then you got it. But in the past few years, with the fast advancements in AI and deep neural network, we have seen embedding taking a greater and greater role in the information retrieval space. Because, with one single embedding model, you can grasp the essence of the semantic of any kind of unstructured data, from images to voices to human natural languages. So it's really convenient and kind of a unified solution for managing the information from the unstructured data, and also do use cases such as information retrieval or search, and other cases like you can also do clustering, which is still some kind of a workload that compares the information between different items, and then and use that to meet the requirements from your particular business need. So the typical pattern of doing this is that you have an embedding model, and you put the unstructured data in, and then it extracts the vector representation out of it. You can think of it as an abstractive representation of the meaning of the content. And the similar the distance of the vector is, or sorry, the closer the distance the vector is, the closer their semantic is. So with this great property, we can do search, we can do clustering, and many other use cases. And that's why we built vector database, because with this new paradigm of managing and leveraging the information, we need a new kind of database or data management platform to do this work for you. And one of the most known use case of that is RAG. I won't repeat about the stuff because it sounds like everybody is familiar with RAG, at least most of you. But the essence of this, this technical graph is that you have the vector database as a major piece of the RAG technical stack, in addition to embedding models, in addition to large language models, so that you can use retrieval to enhance the quality of the answer from large language models. Pretty much leverage any kind of private data, proprietary data sets or documents, internal documents, to help you answer the questions. So in today's talk, I will touch 3 pieces of this. One is how to use Milvus vector database in your RAG stack. Secondly, specifically, how do you use Milvus in the Snowflake ecosystem with Snowpark Container Service? And then lastly, I want to kind of envision a bit on the future of the RAG, which, pretty much every single guest speakers that we have invited in tonight is in this domain, right? We have Tecton working on data pipelines and training. We have BentoML, kind of exploring the frontier of model serving, not only embedding model, but also large language model. And we also have Radarai working on the synthetic data set and evaluation. We'll touch that kind of advanced topic also. So first of all, the idea behind Milvus is that we want to build really scalable, really highly efficient vector database so that it can fuel your production use case. But in addition to that, we also want it to be inclusive, like inclusive in the sense of everybody, like any kind of developer of any level of domain expertise can leverage this technology to build their RAGs or other kind of AI applications. So that we provide two major kinds of offerings. One is the super lightweight. We just introduced this last week called Milvus Lite. It can run as well on your laptop, your Jupyter notebook, and also edge devices. We also have the Milvus, which runs on Docker and Kubernetes, and also on cloud. We have the hosted Milvus offering on Zilliz Cloud. So the experience of using this is that if you just get started with AI development stack and you are getting yourself familiar with, say, Llama Index or LangChain, then Milvus Lite will probably the one with the lowest entry barrier, which can be installed with simply pip install, and then you can start building your vector database into your RAG stack with as simple as import Milvus client and then connect to a local file. In this case, there's no server because server sucks. They are too expensive to maintain unless you have a production use case. So for this kind of learning journey and prototyping, you can just use a local file, which will still materialize all of your data, but every single piece of data is also loaded into memory so that they are good for efficient retrieval. And because this is so lightweight, you can fit it into some kind of Linux-based smart home device, like edge device, that won't have any problem. And say if you have a larger use case and you say you are building a web application and you want to deploy it to a production system, but it's not like super crazy, right? You're still getting started on this. The user starts to kind of growing, and then in this case, you can deploy it into Docker with not one command, but in this case, two commands. First, on the very top, you need to download the script that we provided. And then secondly, you just do, run the script. Pretty much it does the Docker pool and things like that. So that it starts up a Docker container, which has its default, network address and the token credentials. Similar to Milvus Lite, you just need to use Milvus client by specifying the credentials, and then suddenly you connect to it, and everything else stays the same. All of the, say, data insertion logic, the search logic, they stay the same. You don't need to worry about writing different code just because you change the deployment environment. And let's say, the user grows, you raised Series D funding, and now you have 100 billion vectors, right? You're competing with Google. In that case, you can use Kubernetes or Zilliz Cloud if you don't want to manage your own, instance of the gigantic Kubernetes cluster. That's admittedly way more complex than Docker and Milvus Lite, but it's okay. We are talking about productions. So you can use the pre-built operators and templates to start up your Kubernetes instance. And good luck on 100 billion vectors and make money. So in addition to all those kind of flexible deployment mode, we also build Milvus into a lot of the AI development stack in this ecosystem. We work with our great partners to make it ready in, say, orchestration platforms, quality evaluation frameworks. We build demos on how to use this with locally deployed models and things like that. So that if you are using some of the popular AI development stack, you don't need to write your own code. We have written the integration code for you with our partners so that you can just import the Milvus related class from, say, LangChain or Llama Index, and then you can start using it. So specifically, I want to talk about the Snowflake ecosystem because this week, there's a Snowflake conference. Snowflake introduced this so-called Snowpark Container Service, which allows you to run some kind of Docker containers inside the Snowflake domain so that you don't need to move your data outside of Snowflake. And we build this integration by by writing these instructions on how to deploy the Milvus Docker inside of Snowflake account. So the full detail of this, there are a lot of details. The full detail is in milvus.io docs, which is the documentation website of the open source Milvus project. So if you look on the left, we have the integration documents with a whole lot of partners, including our friend BentoML here. One of these is about Snowflake. So the first step to do this is by set up a role and create the database abstraction. Because in Snowflake world, you deal with SQL and you create any kind of even service or any kind of computing logic with the concept of database. So the way to do that is you define roles so that you will use those roles to manage those services that we will deploy in a second. And then once you have the roles, you will create the database abstraction by this. Some of you, if you are familiar with SQL, is pretty much creating tables and things like that. Once you have that ready, you can deploy the Docker image. And the first thing is definitely to download and pull the Docker image so that with the top commands, you can build the image locally. So this actually builds it in the kind of Snowflake environment rather than your laptop or things like that. And once that's done, you can tag the build image with some kind of labels so that later on you can refer to those labels from the Snowflake environment. And finally, you can push this to the Snowpark Container Service. In short, that's SPCS. By pushing this to that, you will see some services running in your Snowflake environment. And once that's done, you are ready to use it as a service. I mean, here what we show is a kind of a demo with Jupyter Notebook, but what you will do in production is very likely application logic that will deploy as another service or another Docker image. And then in that, you can do, say, connect to Milvus client. You can connect to your models, which is also deployed in Snowflake's environment, supposedly. And then you can create the connections and insert data and do the search and do rec, and leveraging all of your existing data in the Snowflake environment. So with that said, we talk about a lot of mechanics in this domain, but what I'm really, really excited is the future of the RAG. Because right now, everybody knows RAG, like everybody working on AI development knows RAG, but it's really, really difficult to make RAG right, because there are just like very easy to use tools like Llama Index and Longchain to help you build Twitter demos, but not a serious production deployment. I think we are trying to do a lot of work with our partners to make these things a bit easier for developers so that you don't need like decades of experience managing a production system or like doing search at Google for 15 years just to build this RAG system. Because admittedly, there's a lot of difference between building the demo on your laptop versus managing hundreds of cores in production and dealing with billions of documents and do search on top of that. And then, control the quality and make them meet your business requirements. So I think there are a few steps towards that. The first thing I want to talk about is, which is also kind of the biggest lesson I learned from my experience at Google Search, which is how important it is to measure and evaluate the quality. Because a lot of the developers on Twitter, they ask about like fancy magics to improve RAG quality. And the cruel reality is there's no fancy magic. There are just like random ideas You can feel free to borrow the ideas. Maybe there are hundreds of them, but if you don't have a systematic approach to evaluate them and then improve your system continuously on top of those ideas, it's going to be fruitless. Because some of the ideas they will result in they will render even worse results. Some of the ideas they may suit others' use case, but not yours, because your mileage may vary. So a lot of the cases they doesn't work for you, and to pick the things that work for you is that by measuring this towards your particular use case. And the way to do that, there's no shortcut. It's there. You have to rely on something, some kind of framework or service providers, or build it yourself. Regardless, you need to have this quality improvement kind of infrastructures built. There are a lot of pieces in it as well. There's like quality evaluations. There's how to collect or gather data sets, or even generate synthetic data set to evaluate the quality. And then you need to build observability into your production system so that you can continuously monitor how well it performs or how badly it performs. And then you have a cycle, building on top of that. You do a lot of A/B testing. You have your release cycle made right. So a lot of things. There's no easy shortcut. That's my main takeaway. But hopefully we'll have a lot of other partners or a lot of startups in this domain. They will make the things a bit easier for you. And the other thing is it's kind of or vision in the multi-model rack. In the last few weeks, there was a few multi-model large language models being released, and they are super exciting. So the way we see it is before, it's kind of the only way you feed the information into a large language model is through natural language, like it's through human language. But that's sometimes it's very limited. Like if I want to find something like some beautiful clothes that just looks like this, it's very difficult to describe that in natural language. I'm no writer. Like I just can't write the feeling what the visual patterns gives to me. So one of the way to do that is by combining the images or other modality of data and text, so that using text as some kind of prompt. Like I have the image which shows something, and then I have some other text which kind of fine tunes the information from the image, or it's kind of slightly correct the information from the image. And in this example, what we show was multi-modal search, which, I mean, you have to do search before you do the full rack, because search is pretty much the R part of the rack. So in this very interesting example that my colleague put together, it's asking, I think it's some kind of mountains in the gold hour in the, in Arabic language, like super fancy. And then combine this query with the image on the top left. So it's like, give me something that has the feeling of the fusion of those two information. And then what's returned are the three other images as well, which have some kind of touch of this first image and the information behind that, which all of them, they show some kind of golden sunlight. The last one, I'm not sure, it's not golden, but it shows some kind of sunlight on the snow mountain. So this kind of use case, I think there will be a lot of interesting use cases, and with the advancements of the multi-model large language model, the next thing, I mean, my personal prediction is that the embedding models will follow that. Because what we have seen is that a lot of the text embedding models, they are applying transformation architectures. Maybe 6 months ago or a year ago, they were mostly using BERT. So there, you can see the pattern of embedding models following the trend of large language models. And as the large language model kind of solves the alignment problem between different modality, then I think there's a high chance that the embedding model will follow up, so that it won't be the current case, which is there's pretty much just clip, and the other, I think, is called visualizer model from BGE. There aren't a lot of open source embedding models that can do multi-model like embedding in on the market, especially for open source. But I think this thing will soon change. And then some like other thoughts on the infrastructure side. A lot of times the developer complains my write quality isn't good. But as someone that worked on search, my first reaction was, well, is your data even right? like, can you just by your with human eyes, can you even find the data? Don't blame your model for even just look at your data. Do you even have the answer somewhere hidden in your data? Maybe you didn't do the data cleaning. Maybe they are scattered around. There isn't a single piece of text that answers the question, or maybe there's your data collection, it lacks some data, or maybe you didn't include all of the documents from your internal knowledge base, like things like that. There are a lot of like nuances to fix and pay attention to in this case. And also, I think eventually right now is like all of the information they were generated to meet humans' preference, like the way from one single fact is most of the data from the large enterprises, they are PDF. Like PDF is really bad for machines to understand PDF. You need like carefully kind of extract the text from the PDF. They have those weird layouts, right? If you have paper that have two like columns, it's not even as good as say markdown files. But if you look at the markdown files, it's pretty much code that's not friendly to human. But as we enter the world where most of the information are consumed by machines rather than human beings, will that even make sense to generate the information as PDFs? Maybe we can just generate the information as deep neural network native data like vectors or something like that. Just a thought. And lastly, there is a lot of exploration in this case, but mostly from the academic world, which is, retrieval is pretty much just a tool for large language model, but you can have other tools. You can have like web search. You can have, I don't know, like some experts, like you can call an expert to get the information. So maybe in addition to just retrieval from a pre-built knowledge base, there could be more tools or more sophistication in the logic extraction that can help the large language model related application to answer the question in a better way. So that there are a lot of experiments in this space. One of the interesting things is that you have the agent-like kind of decision tree. You first decide whether this query even need a RAG. Maybe a large language model is good enough to answer the question, or you can kind of service mesh a few different large language models, and they make different decisions, and then you kind of compare them, or you route the information through different components of the like orchestration of the retrieval tools and other components. And then eventually you combine the information either retrieved or answered by different components, and then like kind of one fusion model to summarize them, and then generate a very kind of elaborated and well thought answer. So with that, I think that's all for my talk. Really enjoy, talking about the future of the RAG and the challenges that we face in the experience of building RAG. So if you want to catch me after the event, I would be happy to talk. Thanks.
Excellent. Thank you so much. All right, Mike, ready to get started? Oh, there he is. Awesome. As we switch out the laptops, a couple of little housekeeping items. These sessions are being recorded, and so both the video and the presentations and any notebooks that are shared will be shared. We'll make sure that they're all up by tomorrow. So you can reach out to us in the event. We're a little bit late on that. So let's talk a little bit about Mike. So Mike is the CEO and co-founder of Tecton, the sponsor of tonight's meetup. So thank you so much. Mike actually had, besides building a really cool startup, he actually has a really impressive background. He was previously at Uber, where he helped to scale Uber to over thousands of machine learning models into production in just a couple of years. So that's really impressive. And it doesn't stop just there. He was also working on search ads at Google as well. So a lot of hands-on experience, which is really great to see, people like Mike then take that experience and turn that into a startup. So Mike, if you're ready.
Let's see if I'm ready. I don't know what to do now. Is there like somebody else who's supposed to press something?
No, it should just work.
Well,
hang on.
All right.
Can you try unplugging it and plugging it back in?
That's a good first step in debugging. Thank you. All right, nice.
Oh, there we
You know
go.
what happened? There's an adapter and the cable wasn't plugged into the adapter. Okay, thanks. And hey, thanks for hosting this event. It's a cool event. So Charles and crew, this is good stuff. Hi, everybody. So I'm Mike. Thank you for the introduction. I'm CEO and co-founder of Tecton. Yeah, and a little extra background on me. So I worked on a platform called Michelangelo at Uber. So helped start the AI team at Uber, and we built kind of like the machine learning that powers all of the different ETA, surge pricing, all of the different things that Uber does in production. And I'm bringing up the production angle because just like the previous talk and all about Zilliz, at Tecton, we really focus on like production use cases. We don't really spend too much time on like, hey, I'm building an internal like search over our documents thing. Is this better? Better volume? Sorry. What we do spend a lot of time on is how do you build an application that is for your customers, for your users, that is powered by AI? How do you power your products with AI, right? And one big dimension of value that people get from AI is in personalization. Earlier this year, I was preparing some stats for our team, and they had just released, one of those big consulting organizations just released like a report about how much value is AI going to generate over the next couple of years. And one of the stats in this report really caught my eye. It said there's going to be $5 trillion, like with a T, dollars of value added to global GDP just based on personalization. There's a couple other numbers, and the total value of AI is $13 trillion added to GDP. But I was like, 5 trillion from personalization, that's crazy. And so if you think about that, that's not from like incremental things. It's not like, oh, we gave slightly better recommendations. It's like we're changing something in a big way. So applications can be like dramatically more personalized. So I want to talk about like one architecture that we think is going to be like a first step, and it's very related to reg and all this stuff we have just been talking about. And so at Tecton, just briefly to introduce Tecton, also we build a data platform for AI. So similar to what was just being said, we're all about connecting your business's data. So your company has all this user data, product data, all this information is really important to it. How do we connect to that and make it really easy for your AI models to use that, either if it's a predictive ML model as features, or if it's a generative AI model as context for that? Like, how do you connect all of your data, something's happening, and you're getting a good prediction or AI generated output on the other side? We're all about helping with that. And so I'll show some examples of how we do that. So let's talk about like a really good personalization. So I have an example I'll talk through. So imagine we're talking about like a travel website, like a booking.com. Like we're going to go take out booking.com. We want to build like a competitor for booking.com. It's going to be way better than what they do. The idea for this product is we just want the website where you go to the website and it just tells you what trip to do. It's not like you don't have to go through a complicated search process and comparing flights and all of that kind of stuff. This thing knows you, it's hyper personalized, and it just hits you with like the homepage is just like, this is the thing for you. right? How could you possibly build that, right? So just as an example, just as an obviously super naive thing, we could say, hey, ChatGPT could run this through some presumably smart model. Say, where should I go for my summer vacation, right? And everybody knows it's going to give you like not the answer that's good for you. It's going to say, hey, go to Paris or something, go to like the most popular place. And why is it saying that? Because it doesn't know anything about you. It knows just like all the information about everybody else, all this other data that it is trained on, right? So how can we get like a way better solution than this? And so there's a lot of techniques that people talk about. People talk about, hey, maybe you can like fine tune a model. Not super relevant here because the model still won't be like connected to you, connected to your data. Can we do some prompt engineering? And that's going to tell the model, maybe ask a question a different way, give it, tell it, hey, spend some more time and think about this step by step kind of thing. But if it doesn't have the raw inputs, the ingredients, as was just being said, it's not going to be able to have the information to give a good recommendation. And maybe we can activate that, aligned with what was just being said, the information retrieval pipeline. So that's something like RAG is really nice for. Maybe we can retrieve information from other data sources we have in the business, in the company, and build something cool with it and connect it to these models. So super kind of traditional way to do this. And so I'm talking about like an augmentation in this talk on top of like a traditional RAG architecture. And so how you could do this naively is, ask, you get some query, right? Hey, where should I travel on my summer break, right? And we can, generate the embedding from that, pass it to our vector database. So pass it to like Milvus, say, hey, give me, some recommendations. You would get a set of candidates from our vector database. These are candidates that are like different cities the model should consider. And then we pass it to the recommender model, right? This can be an LLM that's gonna like not be a predictive ML model that is used in a lot of like booking.com style recommender models, but we can also start building those kind of like real-time recommender models with LLMs. And so what's going to happen here? Well, what we're kind of getting is kind of like a strain, like basically that system is building a stranger who's a travel agent for you, right? So it doesn't have a ton of context, but it's kind of an expert. It's really good at reasoning, but it's going to give you like, hey, go to Paris. It doesn't know enough about you to give you a really smart, a personalized recommendation. But what you really want is like someone who's like your best friend, someone who really knows you, right? And they're a travel agent. So they both have high context about you, and then they have like the really good expertise. They know about all of the places as well. And so, you would want them to say, hey, like, I know that you love sailing and that sailing trip you did last summer, there's this whole big sailing cup happening in Greece this summer. It might be really cool for you to check out. That could be a good recommendation for you, right? So one of the challenges is that we just had these candidates that were passed into the model that are uncontextualized. It doesn't have a lot of information for the model to reason about, right? So we want to add more context and we want to enrich these candidates. And that creates the right context, right? And the context is the relevant information that these models use to understand the world and make decisions. So let's look at like, what does it mean to add context? Well, we can add context about, there's two things we want to add context about. The first is these locations, these cities that, we may recommend, right? What are some things that we might want to know about these cities? Hey, what's the weather like there? What activities are common there? What events are happening there? What's the cost? All of these kind of things. These are just like things that you would intuitively want to know if you're going to make a recommendation for somebody. Interestingly, a lot of these things are not just one-time stats like where is it, but these are things that can be updated regularly too. What's the weather there right now, right? Or what event is happening this week? That could be really relevant for making a recommendation. This gets you some information about the city itself. But there's another side of the puzzle, right? We want personalized context. We want to do reasoning about, hey, I know all this stuff about all these cities. but I need to know about you so I can give you the right recommendation for yourself, right? So we have, you know, a uncontextualized candidate. We just talked about with kind of basic context, which is all the location information. And what about with personalized context? So this is like, how do we pass in the information about you into the context as well? So this is like your personal preferences. Hey, what climate do you prefer, right? Are you interested in history? What kind of budget are you on? What kind of accommodations do you prefer? These can be things that can be inferred from your historical stuff. It can be things that are inferred from what you've just been looking at, any kind of thing, but it will give the model some information such that it can match something to you, right? So some examples of context. Destination insights. This is all the stuff about the cities, right? Cultural significance, safety alerts, what attractions do they have there? What transportation and lodging? You can have a long tail of this stuff that can just help you get better and better recommendations. User-centric data, so everything about you know, historical interactions. Where have you traveled in the past? Stuff like that. Real-time preferences, situational context, economic stuff. Like, is this an expensive place? Can it match your budget? Right? We could have tens of slides of things, of signals that you might imagine someone using in a productionized high value such solution. And I guarantee you, if you go to booking.com, they have thousands of these signals that are being used in their models. What's interesting is the more context, the higher quality context you have, the better the quality of your recommendation, right? So we really want to be like on the right side. For this product to work, we got to be on the right side of this chart, right? We have to have a really high quality recommendation. Otherwise, people are going to go, yeah, this recommendation sucks. I'm going to booking.com. So to build a personalized context, we need to enrich those candidates. And what Tecton does is a feature platform that allows you to join in and integrate all of your different business data sources so that you can easily create, manage, and serve this personalized context to be passed into the model. And so that allows you to get a recommendation that is best friend level travel agent quality, right? It can say Kyoto is perfect for you because, right? And in this domain, the feature platform is orchestrating the creation, the computation of the context, the joining it together, and the serving it. Okay, let me skip this. And so that allows you to go from this to like a really high quality recommendation. So, hey, there's a last minute opening. So this wasn't even available like an hour ago. But there's a sushi chef that's right near you right now. It's a few minutes walk away from your current location, so it's nearby. And they're doing a workshop on a topic that you were just recently blogging about. And they have something on the menu that's like really interesting to you because you've mentioned you like that before. That's really hard to get that recommendation from any product today. But what a cool experience, right? That's a really high quality recommendation. So how can we build something like this? So I'm going to talk about 4 levels of context personalization today. I'm going to blast through those real quick because I'm probably running out of time. So level 0 is easy. This is we don't have context. We don't have context enriching these candidates. And that's how we get this like Paris type recommendation. That kind of puts us at this point on the chart. Level 1 is, hey, let's use some historical insights about you and about a city to generate this context. As an example, let's plug into the data warehouse. Let's use your trips history, your interests that we've inferred over time, your favorite activities. To do this, and so that allows you to have a batch contextualized candidates that are contextualized with batch data, right? To do this is kind of challenging to do this on your own. You need to build these pipelines to retrieve this data, serve it, join it at real time, be productionized. Think of all the things that were just said around the productionization. Then we also want to create some historical data sets from this so we can do evals on historical data points, historical queries to evaluate the quality of these models. It's a lot of data engineering to do. One of the things we do at Tecton in the Tecton platform is we try to make that as easy as possible. So, as an example, where are the last 5 places this person has visited? Maybe that's a really important signal for personalization, right? So in Tecton, we give you a Python SDK So you can write a little snippet of Python code. In this case, we're defining a batch feature view, and it's called users last 5 trip destinations. And all you got to do is write this code, and you get that whole pipeline productionized. So it's taking in trips, so the trips data set, and we're saying, hey, there's a feature that's defined on this, and it is defined as the last 5 such trips, right? And this is defined on a per user basis. So the user entity is the core of that. We can evaluate it. We can instantly use it in our Jupyter notebook, generate all of the historical values of the signal for our whole data set. We run one command and Tecton productionizes this thing. So there's a really big difference between testing something in your Jupyter notebook and productionizing it for serving scale at whatever a real business is running at, right? When you run this one command, Tecton apply, Tecton provisions all of the infrastructure, orchestrates the compute of all of these things, loads it up into an online serving layer, and it's ready to serve and will serve in real time, monitors it, all the things you would have a whole data engineering team do to manage a production service. And then you can just instantly read it in real time across an API from any API endpoint. So that's how you build these signals really quickly in Tecton. And that gets you to a point where you have your data, your recommendations, that they're a next level of quality, right? They're personalized with your history, with your historical context. So we can say, hey, given that you like, I'm using the word history twice, given you have an interest in history and you like going to historical sites, these are things that we can infer from your previous information. This is the kind of recommendation we can give you. Go to this place. So that gets us here. So level 2 now is when we start including streaming data. So how can we use the signals they're currently giving us? So recent interactions, recent behavior, like what were you just clicking on the website? What pages were you just spending time on? That will give us a sense of what you're actually interested in right now, right? So we want to add that into our architecture and make it a little bit more complicated. So session interactions, like what events were you doing on the website? What did you just purchase? What did you just search on the website? What were you just viewing, right? And that allows us to get a much higher quality of context going into the models. This is where the engineering starts getting really hard. You have to deal with streaming data pipelines, which is embarrassingly a gigantic pain in the ass in the data engineering world still, and it should be totally a solved problem, but it's very hard. So you got to build, evaluate, maintain, productionize all streaming data pipelines. And then we're starting to get into the world where this stuff costs real money to run at scale as well. So we've got to start caring about efficiency, and that becomes a problem. And then you need to be keeping an eye on that. So let's look at an example of how you do that in Tecton. So let's think of a feature. In the past hour, what topics was the user watching a video about? If you were just watching a bunch of kayaking videos, maybe we want to send you to a place with beaches or something like that, right? Very similar, write a couple of lines of code in Python. In this case, we're building a recent video interaction topics, and it's operating on the page events data source. And we're saying, hey, give me the last 5 distinct video topics that are coming through your data source, your Kafka stream. And we're filtering to video play events. So we don't, so we ignore other events that aren't related to videos being watched. We can write any kind of Python code here and do any kind of aggregation on that data as well. And this will all run in real time. So this is quickly to create this feature. And then we have all these other steps. We want to test it before we productionize it. Then we want to productionize it, and then we want to use it in production. These steps are the exact same as the previous thing that I just mentioned, right? So it's really fast to go from idea to something's in production. And that allows us to have way better recommendations. That allows us to have, hey, which things were you just looking at? We could include pricing changes, like, hey, the price just dropped 5 minutes ago on this thing. Maybe you should check it out before that last, that supply goes away. And we can say, hey, given that you've recently been looking at trips to Japan and you have a recent interest in fine dining, here's a whole bunch of recommendations for you. That's a little bit more personalized. It's kind of cool. So The next level is bringing in real-time data now. This is a huge, this is a very high quality signal in making recommendations because you can get a much better sense of user intent. What's a good example of a real-time signal? A search query. That's a great, that tells you what the user is looking for right now. And that's very relevant to all the, obviously the Google search stuff that was just being said. But we also want to call out to maybe look up data from other services, stuff like that. So how do we pull data from the application, the app the user is using today? How do we look up the things from other sources of data, right? Like maybe we want to go look up flight prices in real time. We need to be able to look up prices or weather in different locations, especially if we want to get into the world of having recommendations that are relevant for the next couple of minutes even. So this gets us to real-time context. This is where kind of like the engineering problem kind of starts to really explode. Then you got to run, you got to build, evaluate real-time data pipelines and productionize these things, integrating to third-party real-time data sources. And then you have a lot of engineering problems related to balancing between cost and speed. This is really hard to do. I'm going to go quickly through this, but the short version of this is that it's the exact same to define these types of pipelines, define these types of signals in Tecton. How far is the user from the destination that we're considering? Are they in the same country, as an example? We write an on-demand feature view, and this is literally just Python code we're running, and this runs in real time. So it's productionized. It's taking in the information about the device and the information about the destination, and we're able to, we're just writing some simple code to compare the distance between both of these in real time. What's the weather like in this place right now? I'll skip this for time, but we're calling out to an external service. And all the other steps are the exact same. That allows us to have all of this real-time context brought into these recommendations, and we can have that really cool, super personalized, hyper-personalized application recommendation where we say there's a last-minute opening at this thing that's right nearby. And that's how we can build this really awesome Booking.com competitor and take out Booking.com or whatever your favorite travel website is. Bonus level is with feedback. So I'm not going to go through this, but we can imagine adding a layer to this interface where we let the customer or the user go, yeah, that's not for me. I was looking for something more active. I was looking for something that's more cultural or whatever it is. And you can pretty straightforwardly modify this to adapt the recommendations. Okay, quickly closing up. So what do we learn? Context is super important. Doesn't matter what your use case is. If you're building tailored shopping experiences, even if you're having you're building a chat bot, you're recommending content. Content is king. Context is king. Content is king. Make sure you think about building the right context, and you'll have the right outputs. Have really high quality outputs from your AI systems. Personalizing context can have huge impact, but it's very hard to do. It's very hard to build the more personalized you get it. And feature platforms like Tecton can help you configure, assemble, and build all of the personalized context for LLM applications. And then you can build out these types of architectures pretty easily and have really high quality personalization. We talked about productionization. There's a whole bunch of problems that I haven't talked about today. I'm not going to get into. How do you version these things? How do you work with other people on your team on the same thing? Really tough. How do you control which data can be used in these applications so people aren't doing something you don't want them to be doing? How do you debug them when they stop working? How do you ensure things continue to be working correctly? Right? There's a lot of these challenges. So I'll just end here. You can check out Tecton, start building this stuff on your own. Go to tecton.ai/explore, and you can get started with a trial, and you can build some of this today. Thank you very much. Thanks for your time. By the way, we're hiring at Tecton if you're interested, or if you're interested in talking about some of this stuff, I'll be hanging around afterwards. And so I'd love to chat with you. Thanks, guys.
Any questions from the audience? No? Just a little shy? Oh, here we go.
So you're talking about deep pipelines, which kind of hit into the production pipeline of an existing customer, how easy it is for Tecton for them to adapt it? Do they do a little bit approach, or they kind of rethink everything and say, let's build it the new way now?
Did you say how easy is it to get started from scratch?
You have an existing production line, right?
Yeah.
And then should we adapt piece by
Oh,
piece
okay.
Tecton into it?
Basically, you're saying, what if you already are booking.com and then you're like, hey, I actually want to do this. Do I need to like throw everything away? Great. Okay, so the answer is no. We actually never want people to like have to deal with a migration project because migrations suck. So what we do is we make it really easy for for our customers to use this type of, let me just kind of go back here. Set up this kind of thing in parallel with what they're doing today. And then the stuff that they have today, they can either plug in as a data source. So maybe you've got a bunch of data pipelines already, we'll connect to it as an input, or sometimes people set this thing up in parallel, then they have their existing thing and they get two recommendations and they have some way to, merge them in one way or another. But then over time, what we find is that people like the user experience of using this is like kind of night and day different from existing systems. So all the new stuff they build just starts being, hey, I'm going to add a signal here. I'm going to add a signal here, that kind of thing. And over time, they just kind of like let their old thing dwindle away until they decide, hey, let's just turn this thing off. Does that make sense? Yeah, cool.
Yeah, so currently it seems that like it's really service centered, like specifically that user information is service centered, but have you considered it the other way around where you're just getting a lot of user data and I guess feeding that as context to different services? Let's say like personality makes an influence on what kind of content needs to be recommended and in what form, and that that instead of that personality is being fed into what kind of service, what if like services were selected around, I guess, user data instead?
You mean what if the service itself said, hey, I actually want to make a recommendation based on these data points rather than it being pre-configured? Is that what you mean?
Yeah.
So the use case we described as we have a fixed set of context. So everything I just talked about is like, hey, the context is defined by all these data points that I just said, right? And then we have a recommendation that may or may not use all of those things, but we'll pass it into the LLM and it can figure it out. But I think is your question basically, hey, what if you just made all of these things available generally to the service and then it could say what it wanted to use? Yeah, that's a thing that we're actually working on. We call it dynamic context creation. And so it's an augmentation of this where the recommendation model or some variant of that will, some other system right beside it will say, okay, for me to answer this question, what are all the signals that I'm going to need? Okay, let me go pull all of those signals and generate context based on just those signals. And then we can pass those into the model. And so the advantage of doing that is, I said, hey, what if you have 1,000 signals, right? But what if you have 10,000 signals or 100,000 signals? You can't pass all of those in to your model and generate an output in a reasonable amount of time. A lot of these use cases, they need responses in like 0.1 second, right? Like you need to go really, really fast. You need to be more selective. And so that selectivity is actually a frontier of performance in the future. And that's a place where there's going to be a lot of innovation. How do you select which signals go into this thing in the first place? And that's a really important, well, yeah, I'll pause there. Does that answer your question?
Yeah.
Cool. Thanks for the question.
Any other?
Hi. So in the examples that you gave, you kind of stringified all of the personalized data and then fed that as context. How does that compare to, I don't know, like fine tuning a model and then maybe embedding the actual data that you're trying to recommend? So there's a company called Superlinked that tries to just embed everything and then use semantic search. How does stringification compare to a more embedding style approach?
You could do both. They're not mutually exclusive. And there's a lot of scenarios where you might go, hey, actually, I don't even know how to like turn this into a useful signal. I don't even know what the signal I want to build from this thing is. Let me just kind of create an embedding from it. right? And so we, you know, I didn't talk about it today, but in our platform, you can build user embeddings and, you know, let's say location embeddings, for example. And it's totally, it's a great idea to pass those in as part of the context as well. And then you can fine tune the model on that as well. Yeah.
Cool, excellent. So if there are any other questions, you can chat with Mike at the end of today's talks. All right,
thank you.
moving on. Ready? Cool.
Thank you.
All right, we now have the CEO and co-founder of BentoML, Chaoyu Yang, who's going to be talking about his inference platform that he built. And kind of similar theme here, he has experience at Databricks. You know, lots of experience building these big systems in production. And let's see if we can get this thing to roll a little bit better. Is it plugged in? It's not. Oh, there we go. All right, let's go.
Hey everyone, thank you so much for the introduction. I'm Chaoyu. I'm the founder and CEO of BentoML. We are a startup here in SF. We mostly focus on the AI inference and related infrastructure challenges. No matter you're looking to run an open source model or a custom fine-tuned or your own trained models, we offer the fundamental infrastructure for you to run inference workload efficiently on the cloud. In the context of this talk, I will talk about some of the challenges around scaling RAG application that leverages custom AI models. A quick overview of the talk today. I will first cover what are some of the scenarios you might consider using a custom AI model to improve your RAG application. Secondly, I will talk about if decided to run an embedding or large language model as your own inference API that you can control. What are some of the key challenges and how to solve them? And lastly, I will talk about some of the advanced inference patterns that's commonly used in RAG, such as running multimodal inference pipelines and online plus batch offline inference jobs. To begin with, just want to show kind of a very simple RAG system. This is diagram you probably have all seen. It typically comes down to two models that you begin with. And I will start right from there. Typically with the default model that's using for text embedding and embedding search, and the large language model for the response synthesization. Some of the common challenges we're seeing with a very naive approach, as for Mike's slide showing it as Stone Age RAG. Right. Recall, it's not all the chunks that are relevant are retrieved. Precision means not all the chunks retrieved are relevant to the user's question. Sometimes you're working with complex documents and unstructured data that's very hard to fit into this exact model. And when you are generating response for a user, you might want to add certain level of safeguarding and as well as evaluating the context accuracy. There are also tons of evaluation steps that might require running AI models on your own end. These are some of the most common RAG challenges in bringing RAG into production. So I want to start from some of the basic decisions you will be making when building a RAG. The first decision is which text embedding model to use. Assume you are starting from a very simple RAG prototype, right? One thing I always like to highlight, the default text embedding model that a lot of the RAG or large language model app framework recommend is actually ranked number 57th on the leaderboard for embedding models. And oftentimes by fine-tuning and optimizing these embedding representations over your specific data set, you can see significant improvement on the retrieving scores. Similarly, for large language model, a lot of people are thinking about embedding. This may not be for everyone, but a few key questions I often like to ask. First, what capability from the LLM you're using, right? Is it being used for generating understanding a complex context and generating a response? Or is it just used for determining a very simple classification task or multi-class classification?
Another aspect is security and data privacy. Are you working in a highly regulated industry? You need to keep all your data and model security in your own environment. In those scenarios, proprietary models behind the API may not be applicable. A third common scenario is document processing and understanding. Right, documents, real-world documents comes with all sorts of different formats, and you can see PDFs may contain different charts, diagrams, tables. That's kind of hard for a simple text embedding model to understand. A lot of real-world RAG application, in order to really extract information from these documents, we'll need to apply a number of AI models, such as layout analysis, table extraction, or OCR models, to get a better understanding of the document. And there are a lot more, right? In order to understand the best chunking method, you may use context-aware chunking that uses a small NLP model to decide where to split the chunks that makes the most sense for retrieval. There are tons of re-ranker you can choose from. Certainly, you can also fine-tune it on your own data set, which leads to much better performance. And the metadata extract from documentation can oftentimes be used as a way in your filtering and retrieval process, which significantly improve the latency in the retrieval process, because you will be searching through a much smaller space and narrow it down. And those contexts often also provides additional context for the response generation phase. I think this speaks to a lot of what in the previous talk, Mike's talk, using those contexts, extracting those information might be applicable for your personalized response. So the point I'm making so far is there are a lot of AI models and custom models that can be used in your RAG system. Now let's say you've fine-tuned an embedding model or a large language model that you decided to do a private deployment. What are some of the common challenges? Right, this is really where BentoML, our company, is looking to solve, and we've built a large open source community and one of the most widely used open source model surfing libraries. Here I want to share kind of how we look at this problem. So let's begin with a simple text embedding model. So what you're looking here is just a Python class, right? It's loading a text embedding model with a sentence transformer library. It's defined the encoding function that's calling the model's inference encoding, right? We often start with something simple like this that just calls the Python API that loads the model and runs inference. The first step is I have this inference script. How do I turn it into an API endpoint that can be integrated with the external application? Pretty simple and straightforward to do. There are tons of web surfing libraries that can potentially do the same job. But here I would just show, in order to do it with BentoML, super straightforward, just adding two decorators to your class and API definition. BentoML uses the type hints to generate actual REST APIs. And then you will be able to run this service locally, interact with it over the REST endpoint, as well as from the Python client that offers the identical type annotation. Pretty straightforward, and this is really easy for you to test out the API service locally with any custom models. But next, let's get to some more interesting stuff. With an embedding model like this, typically when you're running inference, you're getting one request at a time, unless you're doing static client-side batching, which is less commonly doable, right? Most of the GPU optimization and the model runtime, they're optimized running a large batch of input at one time, right? So if you're doing a real-time online inference service that's processing one request at a time, you're largely missing out on what the underlying accelerator can do for you. So dynamic batching is something that's pre-implemented within BentoML with just one tag. As long as your API are defined to get to receive the input batch and the output batch, BentoML will figure out what's the best batch size in a real time and group incoming requests and put them through the model as small batches. This typically we can see over 3x faster response time and over 2x more throughput for a typical embedding model, and really effective way to just turn on a flag within BentoML serving framework. The next challenge is more about the serving and infrastructure, right? With the model server running locally, now I have to get it into a production GPU cluster and have it deployed. This is something that we've developed at BentoML as well in our Bento Cloud platform. You can easily add kind of documentation on the type of GPU you need for the service, level of concurrency target you want to hit for each replica, and whether or not you want to enable external queue to help handle turbulence of traffic. And Bento Cloud will help handle the scaling aspect, depending on the amount of traffic coming in, help you to auto scale based on the actual traffic. I will coming back to the concurrency in a bit and show what's interesting about it. Next, let's look at self-hosting large language models. I think if you've tried running a large language model locally or looked into inference optimization, this is a pretty heavily researched space. There are tons of best practices for how you optimize a large language model inference server. Here I've listed a couple common options like VLM, MLCLM, and OpenLM. They all perform slightly differently depending on actual use cases. So first, I just want to mention, in order to measure your inference API, a couple key metrics to think about is time to first token. If you're building a user-facing application, that could be extremely important. Like, when does your user start seeing response being generated? Time per output token can be, depending on your use case. If you're doing a large batch job, that might be important. If you're doing parsing the JSON output, you may need the entire output in order to start parsing. That could be important. But for user-facing, generating a natural language response, it might not be as important of a metric to look at. We at BentoML are building the core infrastructure for serving, and we try to support all the common inference backend for large language model. Here is one of the benchmark we ran recently with Llama 3 70 billion with 4-bit quantization. You can see across the 5 different backends we've tested, they perform quite differently. And I want to highlight, this is just for this one model with 4-bit quantization. We are launching a full report very soon. You will see them actually performing even more differently depending on the type of model or the level of concurrency you're running with. So our general recommendation is definitely try out different inference runtime to see which one fit best for your use case. A couple key things to understand is what level of throughput you're looking at. Is it one user at a time, or you are trying to optimize a large amount of throughput? Developer experience can be a significant factor here as well. Some of the backends require model compilation, which adds an additional complication into your build and deployment processes, which again, BentoML, the framework, helps you handle and automate that. Next, I want to, so far we've covered about model inference server. That's given one GPU, how do I get the most out of it, right? But for production workload, you often need to look at scaling more than one GPU, right? Scaling an LLM inference service behind many GPUs. A common question comes here is, how do I auto scale the number of GPUs required for this service? The most traditional approach is just looking at the amount of compute resource utilization. Unfortunately, this metric doesn't work so well for large language model and GPU. A lot of time you may observe a GPU is fully utilized, but then realize it actually can take 10 times more requests due to how batching can enable GPU to get more compute out of it. Another common metric is QPS. Right, query per second. This is pretty commonly used for some of the traditional ML models. But again, for LLM APIs, the cost of each request is quite different. Some requests may be generating 10 tokens. Some requests may be generating 1,000 tokens. They take significantly different amount of time to run, and QPS metrics will completely break how things scale. The gold, I guess, standard here is concurrency-based autoscaling. That turns out to be working really well. It actually reflects the amount of traffic each replica can handle, and it's really easy to configure as long as you run a benchmark and understanding the level of concurrency, the model on the GPU type. Now you have the metrics to decide when to scale up or scale down. Another challenge in building the infrastructure is you are now facing much larger container images, right? I think this is partly a lot of the serverless GPU platform doesn't quite work. With a Lambda, typical Lambda application, you're looking at a Python Docker image file that's 100 megabyte. But with a container image that contains CUDA, VLM, and Torch, that's 6.7 gigabyte, right? And one of the most common optimization we see effective in our platform is stream image loading. You will soon realize the image size with 6.7 gigabyte, 90% of the files are not actually used by your service. By being able to dynamically and stream loading the actual container image, we were able to drastically speed up the startup time of the container from a few minutes to seconds. After the container starting up, the next phase is model loading. That's another huge challenge with all the large model files we are looking at today. I think two very common strategies we're looking at. One is being able to stream loading from remote storage directly to GPU memory. Secondly, is being able to efficiently catch that loading result. Let's say if this model is already previously downloaded on the same node, or download it somewhere else in the cluster, you should be able to leverage that bandwidth and being able to pull down the model as well. Now with much faster scaling capability and understanding of the concurrency-based scaling, let's take a quick look at when you enable request queue and concurrence-based traffic, what impact could it bring to your application? So on the left side is a scaling strategy without an external queue. You suddenly get an influx of traffic and all of them send to the first replica, which is active, right? And now you have 5 other replicas decide to scale up, but when they scale up, those requests are still queued within the first instance. So it takes a waterfall amount of time to actually process all that request. But being able to have that external request queue and concurrency control, you will be able to quickly have 5 instances spinning up and processing those additional requests much faster with kind of the overall latency to your service. All right, so far we've covered deploying your own embedding application and your own large language model. Feel free to check out BentoML on GitHub. There are tons of sample code to help you get started. Next, I want to speak to a couple more advanced inference patterns that's more commonly seen in RAG application. The first one is about multimodal orchestration, which is one of my favorite examples. I've seen a lot of large language model application developers writing input prompt that look like this. Determine if a user query is toxic, reply yes or no. And here are some examples, future learning, and then here's the user query, right? Assuming that's 400 tokens per the entire input sequence, it costs about $200 per 1 million sequence and about 8-second latency to respond that query. An alternative that a lot of application developers are not considering is use some of the more efficient and smaller models. For example, with the most available T4 GPU on Google Colab and maybe a couple hundred to 1,000 or 2,000 samples, you can fine-tune a BERT model for sequence classification. And to determine the same query is toxic or not, it costs 0.07 per 1 million sequence. That's a 2,800 times improvement in terms of cost, and 50 millisecond response time, 160x improvement. The same type of technique is quite applicable in other places in your RAG application as well. For example, you can use a multi-class classification to determine which data set to use for this specific query, right? You could also use the same technique to say, is this user query actually relevant to me being a customer chatbot, right? So this can drastically speed up your LLM application end-to-end response time, as well as helping with cost saving. The next question comes with, now I'm combining perhaps a large language model with a smaller model. If I need to deploy everything in my private, in my own infrastructure, how do I do it? So BentoML actually comes with a nice abstraction for creating distributed deployment with multiple models. Here is an example from the previous slide, and implementing that with BentoML, right? So in the previous slides, we've seen building a service with text embedding and large language model in BentoML. Those service code actually are reusable and composable. So in this case, you can just say BentoML depends a mixture service for large language model and toxic classifier model as dependency. And then you can create an endpoint that calls those dependencies. What happens under the hood is not actually initializing those models within the same instance, because that will be extremely inefficient due to Python skill and how GPU sharing works. But what happens under the hood is BentoML will automatically provision distributed services, find the right size of GPU for each component, and being able to auto-scale each component separately depending on the amount of traffic going into each component. So for example, in this case, the LLM router is just a front-facing layer. It can be run on CPU node. The classifier model can be running on a very small GPU instance, whereas the Mistral model might need a much larger GPU instance to run. We can take that same model orchestration approach to a much larger scale, let's say document processing pipeline, where you have huge PDF files with different type of content and running through multiple models. A very common challenge here is that while submitting the PDF to the inference API for ingestion, a lot of things are happening and you're dealing with a long-running inference task. This is something BentoML offers out of the box as well. Simply change BentoML.api to BentoML.task. This will now translate into a number of APIs helping to manage asynchronous tasks with external queue provision automatically, as well as a client that helps you asynchronously manage how those tasks are executed. This works well for ingesting one document at a time, but I know we are at the Snowflake conference this week. A lot of us are working with much larger scale data set. This is something that we help a lot of our customers architect as well. So assuming you have documents that's living in Snowflake, BentoML services can actually fairly easily integrate it into your batch processing pipeline through Snowflake external function, or if you're using Spark UDF. This leverages the exact same infrastructure we built for real-time inference and async task execution. But what's nice about it is it allow you to right-size in the GPU cluster specifically for your inference task. A pretty common challenge we see people run into is, I need this GPU inference step in my Spark batch processing job. Now I'm upgrading all my Spark nodes to have a GPU. All of a sudden, the cost increased by 20x. But when you look at your workload, 95% of the time, those nodes are actually not utilizing GPU. It's waiting for data to load, it's doing pre-processing, it's running something else, right? But by leveraging BentoML to have those external inference endpoint, you can configure them to scale to 0 and scale to hundreds of nodes, GPUs, when the job is actually entering the stage of running inference. Another thing worth mentioning is that we, a lot of time by leveraging BentoML's bring your own cloud capability, you can actually have those compute happening right next to where your data sits. So with all of that, now we've covered running individual models, composing them, running asynchronous tasks, and orchestrating multi-models. I think I have demonstrated a possible route towards building fully private RAG deployment in your own infrastructure. You can define an entire RAG service within one Python files. You can reuse the components as previously built by the BentoML community. And you can easily scale such inference at scale without worrying too much about optimizations, because the framework and a lot of the, I guess the example projects have already considered those. Definitely check out RAG tutorials under BentoML on GitHub. We are also partnering with the Zilliz team on adding Milvus vector DB as an example. So with that, I want to just quickly summarize the talk. Production RAG often requires running multiple open source or custom models. I really like this idea of compound AI system. That's more and more often we see the state-of-the-art AI system are achieved by composing multiple models. And lastly, to scale such system, you need specialized infrastructure from serving a single model to composing multiple model and running them at scale. Definitely check out BentoML and happy to take any questions.
Questions? Everyone's shy again. Well, he'll be around here if you do pick up the courage to ask questions. So our last talk is going to be a community talk. Are you guys ready? Let's do it. Let's just make sure.
Yeah. Can you hear me?
Yep.
All right. Keyboard assistant. I don't need that. All right. How's everybody doing? This is the last talk. Only going to be 10 minutes, so bear with me. And I'm the co-founder and CEO of Rolari. I've been told that our company's name is a little bit difficult to remember. So here's a little story how it came about. So my co-founder is Italian, and he's trying to come up with a name that rhymes with Ferrari. So this is what we ended up with. All right, so today we're going to talk about synthetic data for LLM testing. So our company, we do generate a lot of synthetic data for a variety of different purposes, for fine tuning, for evaluation. But today we're going to talk specifically about LLM testing. So I'm sure many of you have seen this chart already, that Gen AI is pretty much at the peak of the hype cycle. There's a big gap for it to be actually going to all the production uses cases that people hope for to really revolutionize the way people work. But this gap is huge, as probably like 95% of all of the use cases out there are still at demo level. So how do we cross the demo to production chasm? It's a pretty difficult question, because I'm sure a lot of you have heard, like, and also today it was brought up a couple of times. How do we cross this chasm? It's pretty difficult. And I think there is a pretty good benchmark we can look at, a different industry, which is a self-driving car industry that we can learn from. And me and my co-founder, we came from the autonomous vehicle background. And if you don't know that, this industry was stuck in the demo phase for more than 10 years before Waymo finally released a fully driverless robotaxi service in Phoenix and San Francisco. So how did it make it work? How did it actually become production level? Meaning you feel safe enough for there not to be a driver in a car. So they tested a ton, 20 million miles on public roads. But that is actually only a tiny fraction of how much they tested overall. They tested 1,000x more mileage in simulation using synthetic data. And the reason they had to do that is because all of the AI systems are fundamentally non-deterministic. And you really need a very data-driven approach to ensure that it's going to behave properly in all of the corner cases. And there simply isn't enough data to test it on the real road all the time. So synthetic data is heavily leveraged for these systems to be production ready. And what we want to say, the inspiration for our company is that this doesn't just apply to self-driving cars, but really applies to any kind of complex AI systems and LLMs included. So at the core of what we do, we generate large-scale synthetic data for LLM systems for rigorous evaluation, and also we do systematic fine-tuning for domain-specific models. But like I said, I'm going to focus on evaluation today. And at the highest level, there are two different approaches for evaluation. There's data-free evaluation and data-driven. And when I say data-free, essentially what I mean is a reference-free evaluation, meaning that if an LLM, a ChatGPT gives you an output and you don't have anything to compare it against, so you just ask another model, maybe Claude from Anthropic, to tell you how good is this answer. And that's one form of evaluation, which is reference-free. But as you can imagine, this is not a very good way of judging whether an answer or a RAG or agent system is having good output, because it doesn't have any context of what is right or wrong. So a data-driven approach means that you actually have the ground truth labels, or you have a sense what the correct answer should look like, and then you compare it against that. So a data-driven approach is a much more systematic and correct way of doing this. And there are a couple of different approaches. You can use a public data set, like some of the public benchmarks out there that benchmark LLMs. But the problem with those is that they're typically, the models are trained on it, so the data is contaminated, and also they're not specific to your application. They don't know if it's like a finance-specific application. The generic benchmark doesn't cover some of the use cases you want to test. Well, you can also hand create a data set yourself. But as we all know, this might be extremely expensive and time consuming. So synthetic data is actually a happy medium, and in a lot of cases, it can generate more coverage than you can humanly possibly create. Yeah, all right, so this is the last talk. We're actually gonna give a live demo. Simple demo, gonna go through a notebook, and we are going to do three things. We're gonna build some Stone Age RAG systems, very simple ones. And then we're going to generate a synthetic data set, and finally test and benchmark these RAG systems with the synthetic data set. All right, so first step, RAG systems. What we do here is we collaborate with Milvus, like everybody does here, and we basically use our vector database to load a very long block for the RAG. As you see, 244 chunks are loaded into vector store. And now let's build the simple RAG systems. And here we use three different ones. The first one is a vector store based, meaning that it's gonna compare the query, convert it into an embedding, and then retrieve the similar embeddings in a vector store. And the second approach is as a keyword retriever, which is a more traditional approach before people started using semantic embeddings, and we use a BM24 algorithms here. And the last one is the fanciest one, which we call a hybrid and re-ranker retriever. And all we do here is combine the previous two retrievers, combine the retrieved results, and then we use a re-ranker model to reorder them so that they are better, so that the more relevant ones are ordered higher for the LLMs to process. And here we use re-ranker model Voyage AI. And finally, the last step of RAG is generation. So we use an answer generator here. That's a simple GPT 3.5. All right, so generate synthetic data. Now, how do we actually generate synthetic data? And what we actually want is a synthetic input, output from the result. And we can use as labels to compare the data, right? And using the Rolari generator, all you need is three different inputs. The first one is the application logic, like what is the specific LLM pipeline you're building it with? And here today, it's just simple Stone Age RAG. And then environment data, what we want is basically what is your LLM agent or application gonna run on? And in this case, for RAG, it's usually just a vector database. But also we can take into account such as the structured databases that Tecton was introducing us to, and also, for example, tools that an LLM can call. You can feed all of that to the synthetic data pipeline. And lastly, in order to reduce the gap between synthetic data and real data, you want to feed some examples. So today we just simply generate from the just vector store and using GPT-4o as a model, and generate 20 questions, and let's see how it goes. So this is going to take like a couple of minutes, and what it does is going to sample through the vector database and look for the randomly select chunks and find the ones that it can create the good questions and also the ground truth context answers from. So it's going to take a little bit of time, but let's actually just look at the sample directly so that we don't wait for it to execute. All right, so here is an example synthetic data sample. So you can see here we already have a synthetic question, which is how does COH address overfitting and missing information from its model? And here is a sample answer. And after that, there are two different context pieces that we know is needed to answer this question. And as you can see, this is a multi-hop fact-seeking question. So a specific type of question we want to test the RAG system on. All right, so we have the synthetic data set. Now let's test it. And so in order to test the RAG systems, what you want to do is to select the metrics that's relevant to judge its performance. And for retriever, I think it was mentioned by the BentoML CEO that precision and recall is the golden standard. So precision measures how much real information, real relevant information you're retrieving, and recall measures how completely you retrieve all the information. And for the LLM answer generation, we want to evaluate how correct it is, how relevant it is, and how faithful it is, which is how much it is hallucinating. So we're going to run these pipeline, select these metrics, and then run the pipeline. And because this is going to take a little bit of time, I already ran it like 20 minutes before this demo. And let's skip straight to the evaluation part. So what this does is that it's going to take the data that these three RAG pipelines generated and then compare it against the ground truth labels, which was synthetically created. It'll be another 5 seconds. Let's see. All right, it worked. Okay, so now let's actually look at the data. So we want to plot it. So here are the evaluation results. And so how good are these Stone Age systems? And what we can see from the context recall and precision chart is that the vector store backed one and the hybrid re-rank one are pretty high on recall, almost 90% high on recall. And what it means is that it's almost retrieving most of the relevant context to answer the questions. And the keyword based is, as you can imagine, not as well performing. If we look at the generation metrics, then surprisingly, even for keyword search, the correctness is pretty high, almost on par with the other RAG strategies. So why is that? But if you look at the faithfulness metric, keyword is really low. What faithfulness measures is how grounded is the final answer on the context that's retrieved. So what this tells me is that the LLM is kind of guessing what the correct answer is when the context is not retrieved. So it's hallucinating. So this is an issue they have to fix. Yeah, so that's the demo. So the high level gist I want to share is that essentially what we've done here is that based on the RAG system you provided, we created a large volume of synthetic data and quickly come up with very scientific metrics to understand how well it's working for each component. And when you do further analysis on distribution and look at sample level data, you can really dig deep and understand how to fix some of the small issues and get these systems to production level. All right, and also we are open source. So what I went through here is you can run it yourself. Last slide is that we are hiring. So please, we're a smaller company than the previous companies, so you can just directly email me at e@relari.ai. All right, thank you so much.
Questions?
Hi, what is the prompt that you use to generate the multi-hop questions?
Oh, so actually it's not a single prompt. It's actually a pretty complex pipeline that we use that takes, it's not just using LLM to generate the synthetic data. It's more like using some of the real data and then extrapolate and inject noise to make it more diverse. And a good analogy to help people understand how we generate synthetic data is a self-driving car simulation, which is that the cars are actually collecting a lot of real data in the real world. But what a simulation pipeline does is actually it takes that data, then inject all of the random events into it so that the synthetically create more cases for the cars to test in. And we take a similar approach here.
Any other questions? Well, we're never going to forget how to pronounce your company's name.
Yes.
Ferrari Relari.
Exactly. Ferrari Relari. Thank you very much.
Perfect. Yeah. Anybody else want to announce any job openings? No? Okay. So the final thing is just to let everyone, we have networking still going on, and we can stay here until 8:30.